All right, in this video, we're discussing the concept of a combination. So a combination is a subset of items drawn from a set without replacement. The order of the items in the subset is not important. Okay, so here's an example. You have a set of digits 1, 2, 3, 4, 5, 6. We'll call that set A. And then the subset taken from A are the numbers 4, 5, and 6. So B is the subset, right? If it's a combination, we don't care if you call these 4, 5, 6 or 6, 4, 5 or 5, 6, 4, etc., right? The order in which you state the numbers or scramble the numbers or arrange the numbers does not matter. It's still the same subset. So we count that as just one subset of A. All right, so there are three important things to keep in mind about combinations. The first is that combinations are formed by selecting a subset or R items from a set of N items, right? R and N could actually be the same. You could have a subset where you take all the items from the set, but traditionally R is less than N. All right, point 2, the order of the selected items in the subset does not matter. We just spoke about that, right? Order is unimportant, insignificant. And then 3, the selections are made without replacement. This is often an under thought about idea when you're talking about combinations, but it's important actually. It's very important to help determine when a problem deals with combinations or not. You have to think about this idea sometimes, and that is that the selections are made without replacement. So in other words, once you take an item out of the master set, it can't be chosen again, right? So if you look at our previous example, if you took the number 4 out, you can't use 4 again. 4 is used. We wouldn't be able to get a subset of 4, 4, 4 because we've used up 4 once we take it once. There aren't any other 4s to be taken, so it's only represented once in that case. So it basically means repetition of items is not allowed. All right, if a subset of R elements is to be drawn without replacement from a set of N elements, then the number of different subsets possible is denoted by this formula. So if you want to count the number of combinations, this is the formula to do it. This is NCR. C stands for combinations, but it's often read to help make it more intuitive as out of N items, choose R items. That's very easy to remember. So out of N items, choose R items. This is special notation, means exactly the same as this. And then this is the formula. This is N factorial divided by R factorial. So basically you're taking these two items and turning them into a fraction, right? So N factorial, the first one or the bigger one on top, the subset size on the bottom factorial, and then the difference between those two numbers, right? The difference between N and R, subtract them, and that's what you have. So when you're looking at the formula expressed for a particular example, this term and this term, if you ignored the factorial symbols, they would add together to give you this value. Again, if you ignored the factorial symbols. So for example, if you had 10, choose 2, it'd be 10, 2, and then the difference between 10 and 2, which is 8, right? Okay. How do you evaluate this? Well, we'll look at an example of evaluating it in another video, but I wanted to mention that most of the time you want to use your calculator. It's just faster, and it's less likely that you'll make a mistake if you use the calculator. So just remember that N factorial means factorial operation, and what that simply means is that, for example, if you have 3 factorial, it's telling you do a multiplication problem where you multiply all the integers that are positive and less than this number times that number, right? So 3 times 2 times 1 is 6, right? So if you got 4 factorial, it'd be 4 times 3 times 2 times 1. Okay, and then note 0 factorial is going to be defined as 1. So we're going to make that a definition. It's actually very appropriate in counting scenarios that 0 factorial would be 1. For example, how many ways could you arrange no books on a shelf? Well, if you're not putting anything up there, there's only one way to do it. It's essentially done as soon as you think about the problem because there are no books to be arranged, right? So there's just one way to do that. You could think of it that way. I guess it makes intuitive sense maybe, but either way, it's important for the mathematics that 0 factorial is considered to be 1 so that we don't get zeros in the denominator when working out these combinations. The other thing to keep in mind is that this factorial operation gets very large very quickly, right? If you did 10 factorial, for example, it's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's going to be very large, and it very quickly can overflow the memory in certain calculators. With some calculators, you might have to do some cleanup just to be able to get the answer, but you won't encounter that in your statistics class. I think that in all cases, you'll be able to evaluate it very easily with your graphing calculator or your scientific calculator like this one. So let's take a look at how you would do that on a very common scientific calculator that we use in class. Evaluate 5C2. I'm not going to work it out on screen because I don't have an emulator for this particular calculator. I could show you with my other graphing calculator, but we'll do that in another video. Either way, it says evaluate 5, choose 2. Here's how you would do it. It's very simple. You would type 5 in the calculator first, so you'd push the 5 button. Then you would press the PRB key. That key is right here on this calculator. Just hit PRB, and on top you're going to get a set of options. You'll just arrow over with the arrow keys here to the option that says NCR. And once you have that selected, you're going to type the 2. The 2 here is for the 2. So you type the 5 in first. You selected this NCR business, and then you type 2. And then finally, you just have to press the enter key, boom, and you get your answer. So 5 choose 2 is actually quite simple to evaluate, and so would it be for 50 choose 25, right? All of them are very easy to do with a graphing calculator or a scientific calculator like this. And I would venture a guess that probably every calculator that any student is using in this class is going to have a key like this. If it doesn't have exactly labeled PRB on the key itself, look for a shift or a second menu and it'll be above, it'll say PRB. But again, I think all scientific calculators do this today.